Let's jump right in, shall we? Welcome back to the Explainer. If you've been following our deep dives into managing multi-agent development, you already know we've covered a ton of ground. But today is an absolutely crucial one. We're looking at the Day 7 material, which is all about planning and task decomposition. And yeah, you might be wondering, why start a highly technical AI explainer with a picture of Russian nesting dolls? Well, stick with me. I promise it's going to make perfect sense. Because today, we're finally moving past simple agents and stepping right into the wild world of complex, fully managed digital workforces.
So think about it for a second. How exactly do you get a team of autonomous AI agents to actually finish a complex project without the whole thing spiraling into complete chaos? It's literally one of the biggest bottlenecks in development right now. Because without structure, having multiple independent AI agents is kind of like, well, it's like an orchestra where everyone is tuning their instruments at the exact same time and there's absolutely no conductor. Sure, they're making noise, maybe even some good noise, but it's definitely not a symphony. It's just a mess. So today we're going to look at the exact mechanisms the source material outlines to turn all that unmanaged noise into a perfectly orchestrated symphony.
Okay, let's dive into this. Here's our game plan for today's explainer. First up, the planning agent. Second, from goals to subtasks. Third, prioritization and dependencies. And finally, building the system.
Section 1, the planning agent, architecting the system.
Okay, I want you to shift your mindset for just a minute. Put on your hard hat. I want you to position yourself not just as a casual user firing off prompts to a chatbot, but as the actual architect of a massive digital workforce. When you start scaling up, when you've got dozens of specialized agents researching, writing, coding, you desperately need a dedicated manager to oversee the whole shebang. Enter the planning agent. This is a specialized AI agent tasked specifically with dissecting goals and orchestrating the workflow of all your other agents. It's not the one writing the final Python script or drafting that marketing email. Instead, it sits a level above the fray. It's looking at the big picture. Honestly, setting up a dedicated planning agent is the ultimate fix for multi-agent chaos. It acts as the brain of your digital operation, making sure every single agent knows exactly what to do, when to do it, and who they're doing it for. Moving on to Section 2. From goals to subtasks, the systematic breakdown. Right, so now that we've got our digital manager in place, how do they actually process the work? Well, they use this core workflow of task decomposition. Step 1, define the overarching goal. Step 2, break that goal into distinct tasks. And Step 3, shrink those tasks down into bite-sized subtasks. Remember those nesting dolls we talked about earlier? This is exactly how it works. You open the giant goal doll, and inside you find a few smaller task dolls. You crack those open, and boom, you find the tiny, highly actionable subtask dolls. This is absolutely vital. I mean, an AI agent might completely freeze up or hallucinate if you just yell, "Build an e-commerce website" at it. But if the planning agent breaks it all down until it can hand a tiny subtask to a coding agent that simply says, "Hey, write a CSS class for a blue submit button," well, the agent can execute that flawlessly. It's all about reducing cognitive load through systematic breakdown. Section 3, prioritization and dependencies, order of operations. Now, here's a quick reality check for you. Simply breaking a massive goal down into 100 tiny subtasks, yeah, that's not enough to guarantee success. We have to introduce the real-world complications of multi-agent planning because time, logic, and sequence, they matter immensely. And this really comes down to two big concepts. First, task prioritization, literally ranking what needs to happen first based on overall importance or deadlines. And second, dependencies, identifying which tasks physically block other tasks from even starting. Think about it like building a house. Let's say Agent A is programmed to build the roof. Well, Agent A cannot possibly begin its work until Agent B has poured the foundation, and Agent C has framed the walls, right? A successful planning agent has to map these dependencies perfectly, because without that logic, Agent A is just going to be hovering in midair, throwing a bunch of errors because it's trying to nail shingles onto a house that doesn't actually exist yet. What's really fascinating about this curriculum, though, is how it introduces retry strategies to deal with the inevitable hiccups. Look, without these strategies, just one failed subtask causes a total system halt. The whole project just crashes. But a system built with retry strategies, that ensures resilience and continuous operation. Let's be real, even the most advanced AI agents occasionally drop the ball. They might hit an API rate limit, misinterpret a weird prompt, or just generate flat-out bad code. In a lot of ways, they're surprisingly similar to human group projects. Someone is definitely going to miss a deadline. But a robust planning agent actually anticipates this failure. It builds in automatic retries, alternative pathways, and error handling, so that if one agent fails, the planning agent can just reassign the task or try a slightly different prompt, keeping the whole operation moving smoothly forward. Section 4. building the system. The capstone project.
Okay, so we've gone over the core theory from the Day 7 materials, we understand the role of the planning agent, that nesting doll breakdown of subtasks, the strict logic of dependencies, and of course the safety net of retry strategies. Now we arrive at the practical application, the capstone project. When it's time for you to actually build your own project planning multi-agent system, you can't just rely on one of these concepts. You have to synthesize the whole thing. You've got to write the instructions that allow your planning agent to digest these massive goals, untangle the messy dependencies, and execute those crucial retry strategies when things inevitably go sideways. Basically, you're synthesizing all these distinct parts into one cohesive, unstoppable digital workforce. This right here is the exact moment you transition from just experimenting with AI to truly managing it.
Which leaves us with this final, pretty provocative thought to sum up the immense power of what we've unpacked today. If a planning agent can perfectly decompose and execute a highly complex project, what happens when these autonomous digital workforces start planning their own futures? I mean, once an AI system has the architecture to break down a massive goal, logically prioritize every single step, handle its own errors, and manage a team of other agents to actually get it done, the ceiling on what they can accomplish shifts dramatically. It is a massive paradigm shift in development, and it literally all starts with the fundamentals of task decomposition. Thank you so much for joining me to unpack this explainer. Keep learning, keep structuring that knowledge, and I'll catch you in the next